2.2 Thermal Properties and Temperature Memo. Question 1. Explain, in terms of the motion and arrangement of particles, why solids do not expand as much as gases for the same change in temperature. Particles in solids are generally arranged in lattices and only vibrate around a fixed position, whereas particles in gases are free to move around. The forces of cohesion between particles in a solid are much stronger than in a gas, where they're basically negligible. This means that more energy is required to separate the particles in a solid. Explain the term internal energy. Well, it's the sum of all the kinetic and potential energies possessed by all the particles within a body or object. Question number 3. Define specific heat capacity. Well, it's the energy required to raise the temperature of a 1 kilogram block of material by 1 degrees centigrade. The temperature of a 2 kilogram block of metal is increased by 4 degrees, with a heat energy input of 4,200 joules. Find the metal's specific heat capacity. Well, to find the specific heat capacity, we can use the specific heat capacity equation. Delta Q equals mc delta T. So 4,200 is 2 times C times 4. Rearranging to make the specific heat capacity the subject of the equation, 4,200 divided by 2 times 4, we get 525 joules per kilogram per degree. Question number 5. Describe 3 differences between boiling and evaporation. Well, boiling occurs throughout the liquid, whereas evaporation only occurs on the surface. Number 2, boiling actually requires energy input, whereas evaporation occurs without any energy input. Number 3, boiling will only occur above the boiling point temperature, whereas evaporation will happen really at almost all temperatures. Question number 6. Describe how temperature, surface area, and air movement over a surface affect evaporation. Temperature will increase evaporation as more particles will have the energy to overcome the forces of cohesion. Surface area will increase evaporation as there's more surface for the particles to leave. Air movement over the surface will increase evaporation by reducing the concentration of particles in the vapor above the liquid.